Hello everyone. In this video, we talk about the basics of Python programming, such as setting up working environments, assignment logical and comparison operators, as well as different types of errors that you may encounter while running Python codes. Each lecture note in this course is a Jupyter notebook. When you use a Jupyter notebook, you're essentially interacting with your code through a web browser. And your Jupyter notebook is organized into cells. Each cell can contain code or text. For example, if I click here, you can see this blue bar here, which shows that this is one cell, and the type of this cell is Markdown. And Markdown is a style of writing documents, which in simple terms means that this is a text cell. And basically, this is a cell that provides some information in the form of text, figures, and the idea is that we don't want to run or interpret this cell as a Python code. Now, if we click on the next cell, you can see that this cell is bigger than the other one. And if I double click on this cell, you can see that now I can see the markdown language that we are using. For example, here we have these three hashtags to have a header. This line creates a horizontal line that you saw when I run this cell. And then we have this asterisk here for itemizing what I am writing here. And also we have some figure that we have inserted here from the web. And you can see that therefore Markdown is very powerful in terms of providing rich text documents. And now you can run this cell or use Shift Enter, and you can see that now we have this very nice form of this text cell here. And by clicking on here, you can see that again, this is a markdown cell or text cell. But if I move to the next cell that we have here, you can see that now this is a code cell, which means that here we have some form of code here that we want to run this cell. So that's how you can recognize the difference between markdown and code cells. Okay, so let's move back to the second cell that we have here, where we talk about setting up working environments in Python. And the way that we do this in this course is using Anaconda. So what is Anaconda? Anaconda is a comprehensive distribution platform and package manager, which is designed to simplify the process of managing Python environments and libraries that we use, especially in the context of data science, machine learning, scientific computing. And the very first step to use Anaconda is to download and install the Anaconda distribution by visiting anaconda.com/download. And you can see here in this figure or in this image, that we have, by installing Anaconda, we have access to Jupyter Notebook and a lot of powerful tools and libraries such as NumPy, SciPy, Matplotlib, etc. So let's talk a little bit more in detail about what Anaconda is. So Anaconda, what it does, it incorporates a powerful package manager called Conda. And Conda, what it does, it simplifies the process of installing, updating, managing various software packages and making sure that their dependencies are handled efficiently and correctly. What this means is that, for example, when you're using pandas that you can see here, you may need some other libraries or packages, such as NumPy. And obviously, we can install these libraries one by one and manually, but the idea is that there are some dependencies between them, and we may ignore these dependencies, which will definitely cause some serious problems. So in this case, the idea is that we want to have these package managers where they can understand these dependencies and be able to handle them automatically rather than we worry about all these dependencies. Therefore, Anaconda and Conda, they work together and they provide a very nice and user-friendly platform with some pre-configured Python environments and libraries, especially in the context of data science and machine learning and artificial intelligence in general. Therefore, my recommendation is to download and install the Anaconda distribution, and you learn how to run these notebooks locally. Okay, so let's move on to the next cell here. So you can see that we start this cell by these hashtags here, right? All these 4 lines, they have these hashtags. And what this means is that these lines of codes that we have here, they're actually comments, and they're just for readability and providing some information, right? So when you write some code, you probably don't remember what you have done before in the past month or so you want to put some comments so that both you and if other people are really like looking at your code understand what you're supposed to do in those sort of like lines of code that you have here. And for that, use these hashtags. So now you can write anything you want, provide some information, and this will not be interpreted as Python code. So here I'm explaining and saying that, well, for a cell, we can start with exclamation mark. And what it does, it indicates that that line should be executed as a shell or terminal command rather than a Python comment or a statement. So why is this useful? So let's say, after installing Anaconda, you want to make sure that you have Conda and Python installed on your computer. And one way to do this is to always check the version of the Python or Conda that you have installed. And if you can get the version information, this means that everything should work perfectly fine. And in order to do this, you can use the -- version flag. So in this case, you type conda -- version, and you can just write this if you're using terminal in Mac or command prompt in Windows. But because we're in a Jupyter notebook, you have to use this exclamation mark. And if I run this, you can see that we get the version number here. And this is great because this means that we have conda installed and is working fine. And the same thing with Python, right? So maybe we are curious to know what version of Python we are using, right? So we run this and we can see that we are using Python version 3. And obviously we have these 2 numbers here, but what we really care right now is that we want to make sure that we are using Python version 3. Okay, so in the next cell, which is a markdown cell or a text cell, you can see that we talk about different ways of running Python code. So the first one is Jupyter Notebook, what we are using right now. And in this case, we talk about the fact that when you're running a Jupyter Notebook, you're essentially interacting with your code through a browser. And you can have different cells where you have live code, rich text elements such as equations, images, figures, links, etc. And then you for running each cell, you can use the run that you can see here or use Shift Enter. So I usually like Shift Enter because it's just much easier and faster. So this means that in this case, if I want to run this line of code, which simply says print this text here, data science, if I run this, you can see that, we get the result, which is printing data science. But we can do a lot more. So for example, we can do arithmetic operations, right? We can use Python as a calculator, plus for addition, this dash for subtraction, asterisk for multiplication, and a slash for division. Something which is not trivial is exponentiation in Python, where we have to use double asterisk, right? So if you use double asterisk, this means that this is exponentiation, right? So in this case, we have print 2 raised to the power of 3. And obviously, if we run this, we get 8. And we can write this as just multiplying 2 3 times, right? So 2 times 2 times 2 is the same as 2 raised to the power of 3, and we get 8. The same thing with division. We can have print 2 divided by 3, which we get 0.66. And the nice thing about Python, as we said, is using packages and modules. For example, the math module provides a wide list of mathematical functions, allowing you to perform complex operations without having to implement them from scratch. And in order, for example, to use the math module, you start by importing math. And then inside math, we have this function called sqrt, which stands for square root. And you have to use this dot here. This is called the not dot notation. This means that from math, we want to use a square root function. And in this case, we are finding the square root of 25, assigning the result to the variable result, and then we print result. And in this case, we get 5 as we expect. But the nice thing is that the math module has a very wide range of mathematical functions. And sometimes you want to really know what functions are included. And the way that you can do this is by just typing the name of the module and dot, and then use tab. So you can see that now we have all these trigonometric functions, finding the ceiling, finding cosine, exponential function, factorial, etc. Right? So you can see that this is a very long list of functions for different mathematical operations, logarithmic functions, etc. that we have here. So let me erase this line that we have. So in this case, we have a very simple example where we want to find the sine of pi over 2. And we know already the result is 1, but if we don't know, we can just run this cell and you can see that we get 1. Okay, so now we have seen one way of running Python code, and this is our preferred way in this course. But there are other ways too. The other option, which is option 2, and I would say this is more advanced or professional, is using Python script with the extension .py. If you recall, for Jupyter Notebook, the extension is .ipynb for IPython Notebook, but for Python scripts, we use .py. And in this case, you need to either use a text editor or an integrated development environment or IDE, such as Visual Studio Code or VS Code. I definitely recommend you to install this if you want to do more exercise about working with Python and different IDEs. And once you work with Visual Studio Code, you can create a new file with the .py extension. Let's say we call this myscript.py or any other name. And then you open terminal or command prompt if you're in Windows, and you navigate the directory or folder that your script is located using the cd command. Cd stands for change directory. And then you can run the script using the command Python and then the name of this script that we have, which is myscript.py. And then the other option is which is option number 3, is to directly open a terminal or command prompt and type Python. And in this case, you have an interactive Python shell. So let's see how these two techniques work using Visual Studio Code. Okay, so in this case, now we are in Visual Studio Code. And what we do here is that we want to create the script myscript.py. In order to do this, we can go to File and then New File. And in this case, we just type the name that we want, myscript.py. And now we have to save this. So I save this script where I have my lecture notes. And here we have this file where we can type any Python code we want. And I want to keep it very simple here. So I'm just saying print. And you can see this is one of the nice things about using an IDE such as Visual Studio Code, because it helps you to actually figure out what functions you use. In this case, it's very simple, it's print. But if you forget, you know that, well, there are all these functions that they start with, you know, PRI, or they include this. So in this case, I say I want to print, and it tells you the syntax or the way that you can use print. But in this case, I want to do something very simple. I want to, let's say, find 2 raised to the power of 3, right? This is what we talk about exponentiation. So I'm gonna save this file, right? So right now it's not like Jupyter Notebook. I cannot directly run this here using Shift Enter. But what I can do is that I can come to terminal that we have here and just write Python and my script.py, right? And if I enter now, you can see that we get the number 8 as we expected. So this means that now we were able to run that Python script. And this is very helpful if you have a very long script file where you have many lines of code. In this case, you know, it's just much easier to put everything in one script and then just use this Python and the name of the script. So this explains the approach 2 or option 2 for running Python code. And for approach 3, we just have to type Python in terminal. And you can see that here we have Python version 3.10.9. And now we can use Python. So I can say, I want to know what is 2 raised to the power of 3. And we get 8 as expected. But I really do not recommend using this if you want to write more than one line of code, because it's not a very nice way of interacting with your code. And Jupyter Notebook or just a Python script, as we saw, is a much better option. And here also we can close Python by typing quit. And as you see here, now we are outside this Python interactive environment that we have. Okay, so now let's close our terminal and talk about the 4th way of running Python codes, and that is using cloud-based platforms like Google Colab. So in this case, you can go to colab.research.google.com and either create a Jupyter Notebook or upload your Jupyter Notebook and be able to write Python code. And the nice thing is that in this case, you don't have to do any configurations because all these packages and libraries are already available. In many cases, you know, what already is installed there is sufficient. And if you look at here, at the beginning of each lecture, we have this button here that says Open in Colab. So if you click on this, you should be able to directly open the lecture in Google Colab if you want to use a cloud-based option. But as I mentioned earlier, I do recommend understanding the process of using Anaconda and being able to managing different packages, especially if you want to really develop your strong skills in data science, machine learning, etc. And what this means is that, you know, we can continue this lecture using Visual Studio Code as what we do here, because you can see that now we are working with actually the Jupyter Notebook that we have, or we can switch to the web-based browser that we have. So in this case, let's just continue using Visual Studio Code since we are already here. Okay, so now let's talk about assignment operators. So what does this mean? So in general, let's say you want to store some information. You want to store the value 5. This will be stored somewhere in the memory of your computer, and the address of that location in the memory is usually complex. So one way is to remember the exact address, but that is, you know, kind of hard. And the idea is that we can just assign this value 5 to some variable, let's say here x. And from now on, if I know what is in that location, in that memory, I can just call x or print x. And this is important because when you say equal sign here, equal sign is assignment operator, right? So x equals 5 we are not trying to solve an equation, as in some other math courses. We are trying to say that assign the value of 5 to the variable x, right? And in this case, also have to select a kernel for running this. And you can see that I know we run this cell here. And now if I print x, you can see that I get 5, right? Because x refers to the location where we stored that value 5. But something to keep in mind is that we can change the value that we have at that location. So let's say in this example, I assign 10 to variable y. And then I'm using this line of code where I'm saying y plus equals 3. So what this means is that I want to add 3 to the y, that variable that we have, and then assign the result to y, right? So in many cases, we just want to change the value of this variable that we have, and we want to add 3 to whatever value that we have already stored. So in this case, either we can use this, y equals y plus 3, or we can use the more compact notation or Python notation of y plus equals 3. So in this case, if I run this cell, I expect to get 13 because we have 10 and we add 3. And you see that that's the case here. We get 13. Okay, so now that we talk about assignment operators, the next one we have to talk about is comparison operators. Comparison operators in Python are used to compare values and return Boolean results. So Boolean results are either true or false. And I want to emphasize that the first letter should be uppercase, right? So we're going to see later, this is right now text, it doesn't matter. But once we get to talking about more these comparison operators and Boolean results, you'll see that this uppercase letter is very important. So what are these comparison operators? For checking equality or equal to, we use two equality signs. Not equal to, we use exclamation mark and equal sign. And then similarly, greater than, less than, greater than or equal to, less than or equal to, right? So these are the main comparison operators that we need to know. So what this means is that, let's say, we have assign value of 5 to x, assign value of 5 to y, and now we want to see whether x is equal to y or not, right? True or false, right? In this case, it should be true, right? Because x is equal to y. And if I run this, you can see that we get true. How about the next cell that we have here? So we have a equals 8, b equals 8. It looks like a is actually equal to b. But what we are asking is that, is a not equal to b, right? And this statement is obviously false because a is equal to b, right? So that's why you can see that here we get using the comparison operator. How about the next cell, right? So we have two variables, m and n. M is 10 and n is 7. Is 10 greater than 7? The answer should be yes. Or in programming terms, it is true, right? So that's the Boolean result that we get, true or false. And in this case, it is true. But obviously, if I experiment with these, right, and say like m less than n and run this, we get false, right? Let's put that back the way that it was originally, and we get true. Okay, so we talk about assignment operators, comparison operators, and the next one is logical operators. Logical operators in Python are used to perform logical operations and manipulate Boolean values. And the main logical operators that we need to know of are and, or, not. So the and operator returns true if both conditions on its left and right are true, right? So the both conditions on its left and right should be true to be able to get true. On the other hand, with the OR operator, we need at least one of the conditions on its left or right to be true, right? So this means that if one of them is true, then we get true. And the not operator basically returns the opposite Boolean value, meaning that if we get true and use not, then it's false. And if it's not false, then it's true, right? Because we only have two options. So let's look at this example that we have here. So in this case, we have a equals 8, b equals 3, right? The first part is that is a greater than 5? And that is true, right? Because 8 is greater than 5. And then on the right side, we have b less than 2. And obviously 3 is not less than 2, so that's false. But here, since we have at least one true, we get true for the result of this or that we have here, right? Because remember, for or to return true, we need at least one of the conditions to be true. But if I use the exact same example and use and this time, you can see that now we get true and false. And in this case, we get false because both these conditions should be true for this AND operator to return true. And let's finally look at the example for not. So in this case, we assign true to the variable c, right? So this is a Boolean value. And we say not c, which means that not true, and the opposite of true is false, right? So that's how we get that. And then for next cell, we want to talk about something which is very important, right? We talk about arithmetic operations and we talk about logical operations. And remember that arithmetic operations will be executed before logical operations. So this means that in this case, we are not asking whether 1 is greater than 4 or not. We are saying that whether 5 plus 1, which is 6, is greater than 4 plus 1, which is 5. And if I run this, we get true. But in general, to avoid any confusion, make sure to use parentheses, right? So in this case, it is very clear that we want to first add 5 and 1, which is 6, and then 4 and 1, which is 1, and you avoid any confusion or misunderstanding. Okay, so now that we talk about different types of operators that we really need in Python programming, let's talk about different types of error, right? As a programmer, you should be very cautious of different types of error messages that you get. And we can classify them into three groups: syntax errors, runtime errors, and logical errors. So what are the syntax errors? Syntax errors is like grammar errors that we may make when we are writing. In this case means that we didn't follow the complete rules that we have, and violated some of the rules that we have. And that's the exact same thing with programming languages, right? So syntax errors means that the code that you have violates the language's grammatical rules. And these errors prevent the interpreter or compiler from understanding what the code is supposed to do. On the other hand, with runtime errors means that grammatically your code is correct, but you run into some problems during the execution of the program that you have, right? So these types of errors are usually not detected by the compiler or interpreter, but rather it will cause some problems during the program's execution. And the third type, which is the most, I would say, difficult one to recognize, is logical errors. In this case, this means that your code is syntactically correct or grammatically correct and run without any errors. You actually get some results, but they are inaccurate or incorrect results due to some flawed logic that you had once you had your implementation. So let's look at a few examples to understand the differences between these, right? So in this case, we have a cell where we have print 2 plus 3, and for some reason, we don't have the other parentheses to close the first one, right? So you have a missing closing parentheses, right? So this is something, even here you can see that in this case, where we use Visual Studio Code, it's telling you that something is wrong with these parentheses, right? Because it's not closed, right? Even it's very smart and can recognize this easily. So if I run this cell, you can see that we get syntax error, incomplete input, and even tells you where the missing parentheses is supposed to be. Okay, so now let's look at runtime error, right? So in this case, we have 10 divided by 0, right? So in terms of the syntax or the set of rules that we have for Python, this seems okay, right? You have two numbers, you're dividing them, everything's fine. But you can see that we have a problem, right? We are doing division by 0, and you get this 0 division error, right? So this is a type of runtime error, right? Because this happens a problem during the execution. How about this one? We want to add hello, which is a text or a string here, and then add it to 1, 2, 3, right? So again, you're using addition, you're using the right operator, it looks like it. But once I run it, you can see that you get type error, right? It tells that you can only concatenate a string to a string and not integer, right? So it doesn't like the fact that you have a string here and then you have an integer and you want to add them together, right? So that's a problem that happened when running this code that you have. And now let's talk about logical error. So in this case, you can see that, let's say you want to find or calculate the area of a triangle. You have the base and height. And for whatever reason, you believe that or you think that the area is just base plus height, right? So I can run this cell and I get the result, which is 9, the addition of base and height. But that is not the definition of the area of a triangle, right? So this is a logical error. And as I said, this is the most difficult one to recognize because you usually get some results, but the result is inaccurate, and that is a problem. So we will talk about these types of error messages and how to fix them more thoroughly throughout the semester. But something that you can always use when you get errors is what is called as type checking. And in Python, type checking refers to the process of verifying and enforcing the expected types of variables and objects in your code. So think about it in this way, that any variable or object that you have when you're using Python has a type. And in order to find the type of that object or variable, you can use the type function, like similar to print, where you can use for printing. You can use type to find the type an object or a variable, right? So in this case, if I run this, you can see that we get this message and obviously telling us something about types of these variables or objects that we have, right? So let's use type, right? So that's the function that we talk about in Python, and you can use it anywhere. And find the type of hello, which tells us is str or a string, and then type of 1, 2, 3, which is integer, right? So now we can understand that how this relates to the error message that you have. And as I said, the cool thing about type is that you can use it anywhere. Like, right, we talk about like math module and some of the functions there. So if you use type math.sign, right, as you can see, this is a built-in function or method. So it's very powerful in understanding the type of anything that you have in Python. Or you can say type true, right? So this is Boolean, B-O-O-L, right? So that's something that's been recognized here. And here you can see why it is so important, that uppercase T that we have there. If we don't do that, then that's not anymore a keyword or a recognized variable, and you just get this error that says name true is not defined, right? So remember that this uppercase T, or if you're using false, uppercase F, is something that you have to use, and you can see here the difference in color. One is blue and the other one is just a normal variable or object in Python. Okay, and then the other thing that we have type of like variable or object in Python which you should know is something called none. So what is none? None is a special constant representing the absence of a value or a null value, right? So when you say here result equals none, so we assign none to result, and we can look at type of it, and it actually has a special type. It's called none type, right? So remember that none in general means that the absence of a value or a null value. And then in the next lecture, we're going to talk more about data structures, the way that we can store and organize values in Python. For example, here we are using the type function, and inside that we have these square brackets 1, 2, 3. So it seems that we want to store 3 values. And if you look at the type here, this is a list. So we're going to talk about what a list is in Python and other data structures. And finally, you can see that at the end of this lecture, we have this part which is labeled as homework 1. So this is your first assignment. And in this case, you have 10 problems that you should work on them. And the idea is that these things are not necessarily something that's been exactly explained before, but what you have already seen should be enough to be able to get started working on these problems. And this is very important for improving problem solving skills using Python. For example, in the first case, you want to compute this ratio or a fraction 3 times 2 over 2 raised to the power of 3 plus 4 divided by 2. And what you do here, you can create some cells here. So you can insert a cell below this one and write your code, and then you submit your Jupyter notebook on Canvas. So my expectation is to at least have 10 cells where you have the solution to each problem, and your grade will be calculated based on uh, the level that you have completed each problem.